Hello everyone, this is Mr. Griffith. I am recording this lab just in case that you are not able to complete it during class, or if we were working on some other things like Assignment 6, and you want to be able to see how this lab goes down, and be able to get a look into how does stellar fusion work using something as simple as Play-Doh. We are going to start with, we really don't need a lot. So we're going to say the blue clay balls, or Play-Doh in this case, these are our protons. And the green ones are going to be our neutrons. So, yep, of course, the extent of my football knowledge is good old Seahawks colors. So, each blue ball is a proton, each green ball is a neutron. It is important to know that when we fuse these, like connecting them like so, please do not mix up the colors, just like lightly touch them together so they don't separate. I am borrowing these from someone else, so we just gotta make sure to be neat and tidy. So we're gonna start with one clay ball, and once again, what element does this represent if it's just one single proton? We're not going to worry about the electrons. So I know, looking at the periodic table, the element with number 1 for its atomic number is hydrogen. So this represents a hydrogen atom, and then looking at the isotope name, remember that includes, so it's our element name plus our atomic mass. So we look for a mass of 1. Because we have one atom to start with. So it would be hydrogen 1 or H1 as the symbol. I'm not going to go through all of these, but I am going to be showing off the picture. So this is number 1. Just a single blue proton. That is a hydrogen atom. Next, it asks us to fuse blue and a green together. So they fuse, and they're just going to lightly sit next to each other. And now we have something new. We still only have one proton, keep that in mind, but now we have a proton and a neutron. So which element does it represent? It should still be hydrogen. I know because of the singular proton. However, we are now have two things in our nucleus, one proton, one neutron, therefore it is hydrogen 2. Now we're going to just keep on going. So we're going to fuse yet another blue ball or atom into this, and this makes a new atom, a new element actually, because we have more protons. So we have, so this is number 3 as we have been talking about. So this is 2 protons, 1 neutron, which lines up with atomic number 2, which is helium. So I would call this one helium-3 because there are 3 particles in the nucleus. Then we are to repeat steps 2 and 3 to create another nucleus identical to what we have. Okay, so we are going to just essentially make, boom, right, 2 protons, and over here we're going to grab a singular green neutron. And so we now have 2 helium-2 or helium-3 atoms, and when we fuse these together, so we just put them together, we now have 4 protons, and 2 neutrons, so atomic mass of 6, atomic number of 4, that gets us to be about beryllium. However, let's see, so we have the isotope name, and then drawing a diagram to show the fusion of these 2 nuclei in step 4. So you would basically start with your 2 nuclei. We're going to draw some arrows, and I will model this in class to show how it works. So pay attention to the data table copy of the assignment. In stars, the nucleus created in step 4, so done. will release 2 protons due to the nucleus being unstable. So we're going to remove 2 of our protons, and then we look at what element this is. So I see blue as the protons, green is the neutrons, so let's see, that would be what? 2 protons, atomic number 2, atomic mass of 4. From here, I would like you to write down the isotope name yourself and the element name yourself. Now we're going to repeat steps 2 through 5, so we're going to create 2 more nuclei identical to what we have. So then fuse all 3 of them together. So I'm going to pause and then I will be right back. Alright, I am now back. So I have created 3 of these in total. They all have, once again, our atomic mass of 4 and a atomic number of 2. So if I were to combine all of these together, makes like an interesting triangle right now. That's not necessarily what it becomes, but let's pay attention to how many protons we have. So I count 1, 2, 3, 4, 5, 6. And then I also have 1, 2, 3, 4, 5, 6 of the neutrons. So I believe that would be atomic number of 6, and atomic mass of 12. So what kind of atom does that make? Again, I will leave this one up to you. However, down in our drawing a diagram below, what we would do is basically think about, you would take your 3 atoms, and we're kind of like, think as literally adding them together. So 1 plus this one plus this one plus this one equals the whole giant one. Is it possible to build up to nickel 56 by this process using only helium-4 or multiples thereof? Surprise, surprise, that's what these are. So think about whether or not to, I would say, look up nickel. I believe the atomic mass number, let's see if I can find nickel up there. There it is 28, and 28 versus 56. I encourage you to think about the math for this one, see if we can actually get there, and how many nuclei would we need. My advice is to look at the atomic numbers, so seeing how many times we need to make these 2 atomic numbers, the atomic number of 2, up until nickel's atomic number of 28. So then we think about, in stars, iron 56 is created from nickel 56. So what must happen in the nucleus of nickel 56 in order for this to occur? So if I were to look for nickel and I were to find iron, it is only 2 away back at 26. So I think, okay, do we have to lose any protons? Do we have to gain any protons? And then what happens to the mass? What happens to the atomic number? With that in mind, if you complete this in class, you will have maybe not blue and green Play-Doh, but you will wind up with this funky shape. So the rest of the questions are post-lab questions. So some of it is insight into what we can do, and like maybe further questions, further processes. Have a good night.